Hi, this is Lalit Vasist. I welcome you on the Engineering Made Easy. In the last video, we discussed the communication system. You also learned about the basic building blocks of electronic communication system. Although we covered the communication channel in the last lecture, but now I will tell you detailed information about the communication channel and various types of communication channels that are used today for the transfer of information. So here I am going to define the channel. What is a channel? Let's define it. A channel is the medium through which the message having some information travels from the transmitter to receiver. The message propagates through this physical medium. So let's write this definition. A channel is the medium through which the message having some information travels from the transmitter to the receiver. Okay, so here I will discuss 4 types of communication channels that are common nowadays. So here we will discuss the following 4 types of communication channels. These are: number 1, mobile radio channel. The second one is telephone channels. Okay. Third one, optical fibers. Fine. And the last one is satellite communication. Okay, so these are the 4 different types of communication channels. Now we can further broadly classify these channels again into 2 types. So the channels can again be of 2 types. It may be a point to point channel, or it can also be a broadcast channel. So point to point channels and broadcast channels, these are the 2 further classification of the channel. So now we will see what is a point to point channel. Point-to-point channels are the channels that connect one transmitter with a single receiver. So let's understand it with the help of a diagram. So if we have a transmitter and here we have a receiver, so if it connects one to one, then it will be a point to point channel. It is an example of point to point channel, right? So point to point channels, I'm going to give you a few examples of point to point channels. So these here are the three different examples, like wire lines, okay, microwave links, or optical fibers. Optical fibers. These are the three examples of point-to-point channels. Other type is the broadcasting channels. Broadcast channels connect a single transmitter to multiple receiving stations simultaneously. So we can draw the schematic of a broadcast channel like this. Okay. In broadcast channel, here we have a transmitter here we have a single transmitter, and these are the receivers. Receiver 1, 2, 3, 4, single transmitter, and multiple receivers. Here I am just giving 4 receivers for example. These are the receiving stations. These all are receiving stations. So the example of a broadcast channel can be, this example can be the satellite communication. Satellite communication. Clear? Satellite communication is an example of broadcast channel. So let's delve deeper into each type of channel one by one. We will see here all the channels one by one. So first comes the mobile radio channels. As we have seen that these are the 4 types of channels that I have mentioned earlier. So mobile radio channel, we will see all these one by one. So let's take mobile radio channels first. Mobile radio channels. These can be illustrated like this. This is a tower having some signal, and here is a mobile phone which is getting the signals. Okay, so let's do the diagram. This is a simple mobile phone. So mobile radio channels, we all are familiar with the mobile radio communication nowadays. It has introduced mobility or movability into the public telecommunication networks. So the mobile radio channels does not involve any line of sight for communication. The radio propagation happens mainly because of the two phenomena called as scattering and diffraction. There are two phenomena called as scattering and diffraction that are responsible for the mobile radio channels. So let's write it. Two factors are responsible for this. First one is scattering and the other is the diffraction. Scattering and diffraction. So the scattering happens from the surface of buildings that are present in the surroundings. These obstacles are also responsible for the diffraction of signals. Because of this scattering and diffraction, the energy reaches to the receiving station via different paths. Okay, via different paths that leads to different time delays. This problem is called as multipath phenomena. So this problem is the multipath phenomena. I think it's clear to you. So now let's come to another channel type, which is this was the first one. Let's consider the second one, the telephone channels. Telephone channels. Telephone channels are used to establish an end-to-end communication link on a temporary basis. Switching mechanism is used in telephone networks that is known as circuit switching. So in telephone channel communication, the sender speaks into the microphone. These sound vibrations are converted into electrical signals that is to be transmitted through the wired channel. At the receiving end, these electrical signals are converted back into the sound signals. The telephone channel can pass frequencies between 300 to 3100 or 3100 hertz, which covers all the frequencies that are present in human speech. So I think it's clear to you. telephone channels. So these telephone channels, this is all about telephone channels, I have told you. So I think you are getting the point. Now let's come to another channel, optical fibers. Third one is the optical fibers. Is the telephone channel clear to you guys? Okay, it's quite simple actually. So I was not going into deep. I will have many things to tell you about this optical fibers. So we will, there are lots of concepts in this, so I will go in detail of optical fibers, a little bit detail. We will see other things in separate videos about optical fibers. So let me draw the diagram. How does an optical fiber look like? This part is called cladding, 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 and this inner part you can see is called core. So it has the central axis is called the core, and this outer layer, this outer part is the cladding. So the light rays propagate only through this core part, like this. This is the direction. This happens because of the total internal reflection. Before going further, let me explain you the concept lying behind this optical fiber. How does it work? Let's suppose the refractive index of this core is mu1 and the refractive index of the cladding is mu2. So what is the refractive index? Refractive index mu is equals to the velocity of light in vacuum divided by the velocity of light in the medium. Okay, speed of light in vacuum divided by speed of light in any medium in which the light is propagating is called refractive index. And this is the refractive index. Clear? So here I am taking, as I have told you, mu1 and mu2. Mu1 is more than or greater than mu2. That is, the refractive index of core is more than the refractive index of cladding. So now let's come to the concept. How does this happen? How does it work? What is the underlying principle behind this? This works on the concept of a total internal reflection. The light propagates through the core with the help of the underlying cause behind this propagation is the total internal reflection, TIR. So how does this happen? Let's suppose this is a surface separating two mediums. Here is the rarer medium having less density as compared to this one, which is denser medium. Yeah, and here is the normal. Okay, so when a light travels through a denser medium to a rarer medium, then it deviates away from the normal. So its original path would have been in this direction, but it has deviated to this direction. It has diffracted away from the normal. The reverse case happens when the light travels from rare medium to denser medium. It comes closer to the normal. So in this case it is going away as it is passing through dense to rare medium. So if we, this is, suppose this is theta 1, this is theta 2, it is very clear that theta 2 is more than theta 1 because of deflection, sorry, because of refraction. So now if we keep on increasing this angle, then this will again come down. So at some point the case will be like, let me draw this in the same diagram. It will be like something like this. At some angle called as theta c, this is called as the critical angle. At this angle it will bend towards away from the normal, and at some point, at some angle called as theta c or the critical angle, it will move parallel to the surface which is separating the two mediums. So this theta c is the critical angle. So if we keep on increasing this angle, then at some point it will again move into the same medium like this. This is the normal. Clear? At this point, this is theta 1 and this is theta 2. Theta 1 is equals to theta 2. Since it is a simple reflection, it is called total internal reflection. Total internal reflection, TIR, because the ray has been reflected into the same medium totally without any loss. So it is called as total internal reflection. So now let's again come to the optical fiber, what is happening inside this. Since I told you that here mu1 is more than mu2, so this is the denser medium and here is the rarer medium. Mu2 is a rarer medium. So when the light moves from, suppose from here, dense medium to the rarer medium, this is the surface, that here is the normal, imaginary normal. So the light is moving at this surface which is separating these two mediums of different densities. So it at some angle, that angle is enough, and that angle is more than the critical angle, so the light is moving back into the same medium, that is the core. So this is, here it is the total internal reflection. Okay, I think it's clear. This case is like this. I told you the total internal reflection here, this part same as this. Here it is the total internal reflection, it has occurred here. So it moves again, the same thing happens at this surface. It is again total internal reflection. At this surface again, this is again total internal reflection. So this happens continuously. So this ray propagates through this optical fiber with total internal reflection. I think it's clear. So let's now move on to other point. Now I will discuss the communication using optical fibers. How does it take place? So let me draw a block diagram. Okay, these are the empty blocks, and now I am telling what they stand for. This is the information source, and here is the electrical transmit. Electrical transmit. This is the optical source. Optical source. Optical source may be LED or laser. This is the optical fiber. Optical fiber, the channel. Here is the again the electrical, sorry, here is optical source, optical fiber, then the photodetector. This is the photodetector. If example of an of a photodetector may be a photodiode. This is again the electrical stage, and this is the destination. Okay, this is the destination. So how the things are working here? First of all, let me explain it to you with the help of an example, an easy example. Suppose when someone speaks, then it creates sound signals. This sound signal is converted into electrical signal. Okay, and then electrical signal into the light signal using lasers or LEDs. Then at the receiving end, again the signals this is again converted into the sound signal using transducers. So how the things are performing their job is, here maybe some non-electrical signal, like maybe speech, then it will be converted into the electrical signals. So here the processing stage of electrical signals take place after conversion from non-electrical to electrical signals. Then with the help of optical source, as the optical source emits light and takes the electrical signal as input, it converts these electrical signals into optical signals or the light signals. And through this optical fiber, this light signal is carried to the receiving end. So in this optical fiber, no electricity travels, only the light rays propagates, as I have already told you, with the help of with the phenomena total internal reflection. Okay, so it reaches at the receiving end, and at there photodetector is used to convert this light signals again into electrical signals, as it is sensitive to the photons of light, and it emits electrons, which creates electricity, which is responsible for electricity. So here the electrical signals, the photons are again converted into electrical signals. At this stage, this processing of these electrical signals takes place, and again at the destination it is again back converted into the non-electrical signals. So it acts as an energy converter or transducer, where the electrical signals are again converted into non-electrical signals. In our example here, the conversion of electrical signals to sound takes place. So I think it was clear. Now what was this? This was the optical fiber communication. Okay, so now let's see some benefits of optical fibers. These are some benefits. What are these? The very important benefit is the very large bandwidth. It may be up to 2 into 10 raised to the power 13 hertz. It's very big, very large bandwidth. Another benefit of the optical fiber is negligible transmission loss. Let's write it. Negligible transmission losses up to 0.2 decibel per kilometer, which is really negligible. Third one is small size. It is very thin, very lightweight also. Very flexible. and also it is immune to electromagnetic interference. Immune to electromagnetic interference. And the last one is no electrical shock hazards. No electric shock. Electric shock, there is no risk or hazard of electric shock, as only the light signal travels through this optical fiber, not electricity. So let's come to the fourth channel of communication, that is satellite channel. Fourth one is the satellite channel. So satellite communication can be used for continental or even for intercontinental communication. It can cover large areas and also the areas which are not easy to access using other conventional modes of communication, like wired communication, optical fibers, like this. The communication satellites are situated in the geostationary orbit, which are at an altitude of 22,300 miles from the Earth, and it is placed directly above the equator on an eastward heading. So let me draw a diagram so that the concept becomes more clear to you. This is a satellite, okay, in the space, and here we have a station, so here is the diagram of a satellite communication. These are the two stations which are situated on the Earth, and here is the satellite itself. So here this Earth station, in this example, acting as a transmitter, and this is the receiving station. So it has some information that it wants to transmit to this receiving end, so it takes the help of a satellite. Here it sends the message to the satellite. Since it is at a very large distance from the Earth, so the signals get weak, so the amplification of the signal takes place in the satellite, and also the frequency is modified as per the requirement. Then it sends the signal back towards the receiving Earth station. So the signal is recovered, signal is received at this and using the satellite channel. So as I told you earlier that the satellites are placed in the geostationary orbits. So why they are called as geostationary orbits? Because the satellites that are placed in this geostationary orbit, they appear stationary from the Earth as it completes one revolution around the Earth in exactly 24 hours, which is same as the time taken by the Earth to complete a rotation on its own axis. So it appears stationary from Earth. So now that's all that I wanted to share with you about various types of communication channels. In the upcoming videos, we will discuss more fascinating things about science. You can subscribe my channel Engineering Made Easy to get more such useful and interesting information. Thank you for being with me. Bye bye.